trigonometric functions and graphs question from 2022 was quite a good question to come up, right? So if you saw this question coming up, you probably should be quite happy, right? Because it was a 50-mark question, and there are definitely a few challenging parts in there, but like there was a lot of very manageable parts, okay? And I'm always going on about a well-prepared student. I'm not talking about the most intelligent students or the most gifted students, but the most well-prepared students would have got on very well here, right? Because there was nothing too out of the ordinary here. Now, if we look at the question there, so part A, this was 15 marks for part A for filling out the table and drawing the graph, right? So you were getting marks for free here, and very few people made any mistakes with this. Most people filled out this table without even doing any rough work, but the people who did the rough work, all you're just doing is just subbing 0 in here for T, subbing 2 in for T, because 1 is done for you, 3, and then 4, 5, 6, 7, 8, okay? And you'll see that you're kind of a pattern here emerging, and you're just plugging your values in there, and very few people made any mistake there. Just watch out, make sure it's in radians, make sure your calculator is in radians. And once you have your table, then you're just plotting this on the graph, and again, very few people made any mistake here. Just being nice and careful, as neat as possible, doing it in pencils. You don't even need the coordinates. Drawing your graph, and there we go. And everybody should be familiar with that distinct cosine rule function. So for part A and B, that was 15 marks altogether. Okay, so it was very difficult to lose marks really with that. So you're off to a great start. Now C then was actually not very well answered, right? It's a relatively simple question. Period, range are the two most fundamental things really when you're doing trigonometric functions and graphs. And when you have the graph already drawn, most people were able to do this without doing any calculations at all. They were able to do it from the graph because they knew that the period is where does the graph start to repeat itself. Okay, so it starts here down here at whatever value that is. It goes through one full cycle and it repeats itself here after 6 seconds. Okay, so that's your period in this case is 6, right? So that's how you get the period. Whereas the range then is the lowest point in the graph to the highest point of the graph. Okay, now you can't really tell that just by looking at the graph, but if you go back to your table, you'll know that the lowest point, or the point when t is 0, was 12, and the point when t was 3 was 132, right? So without any calculations, if that's all you wrote down, that was your 5 marks there straight away. But if you wanted to use, some people tried to use the formula, and you do need to know these formulas. Sometimes you'll have to use this formula, and it's that if you want the period, it's 2 pi over c. Now c is the number before the t in this case, which is pi over 3. Right, so don't be turned off by the fact that that's what a lot of people get turned off because there's a pi in there, right? But look what happens when you do 2 pi divided by pi over 3. The pi's cancel and you're just left with 6. Okay, same with the range. Okay, so that's your A, that's your B, and if you do A plus B, you actually end up with 132, and if you do A minus B, you get your 12. So there are your values, and actually it doesn't matter if you mix these two up. If you said 132 and 12, that's full marks as well. But just traditionally, it's good to start with the smallest one, the lowest one, and finish with the highest one. Okay, so you didn't need to use these formulas, but that's what it would look like if you did. Now, this was a great question then, right? So this was the question really that, this was a real proper higher level question, okay? It was a novel question. Anybody who came into this exam would never have seen a question like this before. It was a pure problem solving question. Now, I'd say maybe about 5% of the candidates got this out, okay? So just keep that in mind. Let's look at what they're actually asking for here. So in a 50-minute period, so look, we're dealing with minutes now, we're dealing with a 8-minute period here. But in 50 minutes, in any 50-minute period, what's the greatest number of minutes for which the point A could be higher than 42 meters? Now, I'll tell you about the mistake that a lot of people made, okay? And it's kind of an understandable mistake, right? It's that when they saw greatest, right, straight away they just started thinking about calculus, right? And greatest, what's the maximum number of minutes? Maximum means calculus. Calculus means differentiate it, put it equal to 0 and solve. But that was a bit misleading there. And I understand why people would have made that mistake, but it was actually nothing to do with calculus. If you tried to use calculus in this case, you actually got no marks. Okay, so what are they actually looking for here? Well, look, we want to know when it's higher than 42 meters. Now, 42 meters is about here. Okay, now if you remember from your first point, 1 corresponds to 42. So it's in this simple period here, in this first 6 minutes, it's above 42 minutes from 1 all the way to 5. Right? So if you look at your table, it's exactly 1 to 5. So in the first 6 minutes, it's above 42 minutes for 4 seconds. 1, 2, 3, 4. Okay, now the beauty of a cosine wave is that it repeats itself over and over and over again. So in 50 minutes, how many 6-minute periods are there in 50 minutes? Okay, well, in 48 minutes, there's going to be 8 6-minute periods, right? So if we in each of these 8 periods, then it's above 42 for 4 minutes. So in the first 48 minutes, it's above 42 minutes for 32 minutes. Now I'm going to show you a graph of that in a second just to show you. Now, what happens then after that, right? So let's actually zoom out and look at what exactly this means, right? So we know for the first 6 minutes, from 0 to 6, okay, it's above 42 for 4 minutes, and that's the same from in the first 12 minutes. It's the same in the first 18 minutes. So that repeats itself 8 times until we get to here, 48. Okay, so in the first 48 minutes, it's above it for 32 minutes. Okay, but we want it in the first 50 minutes, so there's one more minute, okay, where it's above 42 meters, so it's simply 32 plus 1, okay, because there's one extra minute. It's 32 minutes up to here, and then one more minute. Now, when I did this out before I looked at the marking scheme when I was correcting it, and I was surprised to find that that's actually wrong. Okay, and the reason that's wrong, now it's very close to being the correct answer, and if you got 33, it's 4. You got 4 marks out of 5, right? But the trick is that it's what's the greatest. It didn't say for the first 50 minutes. It's in any 50-minute period. Okay, so just look carefully at this. So if we picked this 50 minutes, so the first minute to the 51st minute. Okay, that's 50 minutes, right? And that's what they were looking for. Okay, and it's above 42 meters for these 8, which is what we spoke about already, these 8 periods. So that's your 32 minutes, but it's actually above it for an extra 2 minutes after that. So the correct answer is actually 34 minutes, 32 plus 2. Okay, now even me explaining that, I'm nearly confusing myself even listening to it. But if you looked into this question very carefully, like hopefully you're following that. Okay, so 34 minutes is the actual answer. If you got 33 minutes, right, it's close enough, right? And it's understandable. You actually only lost 1 mark if you got 33 minutes. And even if you mentioned 6 minutes and 4 minutes above, or if you did any of this right, you got 3 marks, right? So there was a lot of marks going for anything in here, but really only the top students got 34 minutes out in this case. Now this question, the bad news about this question is it's one of the hardest types of trigonometric equations. Okay, the steps are quite tedious, but the good news is it's still a routine question. Right? And I keep going on about the well-prepared student, not the top student, not the most intelligent student, but the most prepared student. No, will have no problem really with this. Okay, now if you're watching this video now and you're not quite familiar with trigonometric functions, then watching this is a waste of time really. You need to go back, look at the very, very basic types, and most importantly, know the steps completely off by heart. Right? And once you know those steps completely off by heart, then this becomes quite routine then after that. Right? So first step anyway is a kind of a preliminary step, and that's where we want to isolate the cosine. Okay, we want to isolate all this. We need to get rid of that 72 and that minus 60. So just a bit of algebra, a bit of balancing, and we end up with this. Okay, and this was actually worth 4 marks if you just did that. Now next up then we get our reference angle. Okay, and we do that by just ignoring the minus here, ignoring the pi over 3, just getting the inverse cos of 38 over 60, which is 0.8848. Okay, now the next step then, it's up to you what you do next. I would always draw the unit circle now next. And basically that 0.8848 refers to this angle in here. But we know that there's 3 other angles with the same reference angle. And it could be any of, our solution could be any of those 3 angles. Now how do we know which one it is? Well, we use cast. Right? And cast tells us that, right? In this case, cosine is negative. And cos is negative in the second and the third quadrants. Right, so the angles that we're looking for is here and here. Right, so it's these 2 angles, okay, that we're looking for. Now, how do we find them? Well, that's pi radians here. If it was degrees, it would be 180. And to find this angle here, we just do pi minus that. And to find this angle here, we do pi plus that. Okay, so that's the 2 angles that technically these are both solutions to that. Now the thing is though, we want to find the second time So you could work away with this if you want, but this one is actually irrelevant. This is the second time, and I'll show you in a second what that actually means. So it's actually only this one we're concerned about. So now your final step is we solve for t. So we, at this point now, we know that the pi over 3t is equal to this. So simply divide by pi over 3, or multiply by 3 over pi, whatever you want to do, and you get an answer of 3.845. Now let's look on the graph what actually that looks like. Okay, so if we look at our cosine function from the previous few questions, we want to know the second time that the value t is at a height of 110. So 110 is along here somewhere. Okay, so the second time is clearly that time there. Okay, and that time is clearly 3.85. Because that's what your answer actually looks like. Now, just bear with me there for another bit, because some people made a small mistake in this but still got a lot of marks. If you picked this one, if you pick this angle and continued down here and divided by 3 over pi or pi over 3, you would have got the 2.15 here. Okay, now that's obviously wrong, right? Because that's the first time. Okay, but you could actually still get the correct answer, because if you got 2.15 and you went to 6, right, which is the period, and you subtracted 2.15 from 6, you actually got back to this. And some students actually did it that way. They had a good deep knowledge of how cosine functions work, and they knew that if that's the period, and if I subtract my 2.15, I'll get back to 3.85 as well. Right, now again, that's kind of hard if you're not extremely familiar with these. That won't make any sense. But just showing you there that some people, if you got 2.15, you actually got what's called high partial credit. You got the highest attempt marks if you got the 2.15. Now, finally then, this was look, they give you a big clue here. Sometimes they won't tell you that it's integration. They could just say, find the average value over 8 from the first 8 minutes. But they tell you it's integration. And there's only 2, maybe 3 applications of integration that you need to be aware of. And one of them is average height, right, which is this. Okay, and most people got that. And actually, just by writing down the formula, and even I don't think you even needed to substitute values into it, but just writing down the formula got you attempt marks in this case. Okay, now I'll show you where most people made the mistakes, because most people were able to substitute correctly into this formula, right? Your definite integrals are 8 and 0, 1 over 8 minus 0, or 1 over 8. But the problem people had was they needed to integrate this. And there was a terrible standard of integration in this case. So how do we integrate? Well, the 72, first of all, goes to 72t, right? So if it was an x, it would be going up to x. But look at what happens here. The cosine goes to sine. Okay, it doesn't change the sign or anything. It goes cosine. The 60 stays the same. The pi over 3t stays the same. But the bit everybody messed up, or the big mistake people were making, was you then divide by the derivative of the angle. Okay, so pi over 3t, the derivative of that is pi over 3. Like if it was 70, the derivative would be 7. If it was 3x squared, it would be 6x. But the derivative of this is pi over 3, so we divide by pi over 3. Okay, so that's your integral there. Right? And loads of people made mistakes with that. Now after that then, you're substituting your 8 into this, and you're substituting your 0 into this, and you're better off leaving that 1 over 8 out till the very end. Right? Substituting that in, that comes out as being 0, so you actually didn't even need to do this part if you want, because it just watch out, if that was a cosine, then that 0 would make it 1. So just watch out for that, just be careful with that, but you didn't need to write this bit down because it was 0. So type that into your calculator, and it comes out as that, multiply by 1 over 8, and it comes out like that. So that was your answer to 1 decimal place. Now, interestingly, so very few people actually got it out fully, and the biggest mistake was with this here, with the actual integration part. But if you wrote down your formula correctly, or substituted incorrectly, if you made a mess, and even if you made a complete mess of the integration part, right, but you substituted your values incorrectly, and you worked it out correctly and got some sort of a solution, you actually got 8 marks out of 10. Okay, which is amazing, really. So even if you made an absolute mess of the integration, you could still get almost all the marks for this.